My name is Ana Ceci.
And today we're going to present you quadratic functions and equations.
A quadratic function, those equations usually give you a parabola when you graph them in the vector.
A parabola, they are these ones. And they are actually three different forms to get in a quadratic equation. So we have first one, that is general form.
We have vertex form.
And last one, we have root form. And in this video, we're going to present every single thing that represents how to graph a quadratic function with already given an equation. This equation is on general form. So first, by looking at the equation, we can get the y-intercept by looking at the number right here, that is 8. And basically this will be my y-intercept. Then it's important to get the x-intercepts. So first, the first thing I would do is take my equation, y equals x2 plus 6x plus 8, and then a factor. So first I do my lines. This is x and this is y. Then I'm going to do little lines to write down the numbers from 1 to 8. To know y-intercept, you look to your y and then count until 8. So it's right here. This is my y-intercept. Then I'm gonna graph my other 2 points, that is the x-intercept, -4 and -2. So -2 right here and -4 right here. I'm going to put my vertex, that is -3, 1, 2, 3, -1 right here. This is my x-intercepts. So but I already have my vertex, my y-intercept, and my x-intercept, and the only thing we have to do right now is just put together all the points, just like this. And that is how you get the graph, is how to graph a quadratic function.
To convert from general form to vertex form, we first have to look at our equation. This is our original equation, and what we are going to do is that we're opening a parenthesis and we're writing our x, our second term, and then on the third term we open a line and leave it blank, and then close the parenthesis, move here to the right, and then open a second line. Then what we're going to do is this term, we're going to half it, so the half of 6 is 3, and then square it, so 9. This one here is going to be plus 9, and then in this line we're going to put the same term but on the opposite sign, so it would be -9. We solve this by concluding y equals x2 plus 6 plus 9, and then 5 minus 9 is -4, and then this we rewrite it as in y equals, we open our parentheses and we put x, we put our second term, the half of it, and with the same sign as we had it in the first place, so we put plus 3, close the parenthesis, square, and then our term that we had at the end that we concluded from plus 5 and -9. So it is -4. This is our end answer. How to obtain the equation of a quadratic function from a graph. In this case, we're going to use vertex form. We want our equation to be on vertex form. So we're going to take a look in our graph. Here we can look at the vertex, and right here we can see a random point. So we're going to look is 2 and 2 comma -1
we're going to substitute it right here. So y is equal to ax minus 2 to the second plus minus 1. That eventually is minus 1. Now, we have already this. 1. My x is 0. And this is what we get, minus 2 to the second minus 1. And then we put 1 equals a minus 4 minus 1.
Now we're gonna convert from vertex form to general form. This is our original equation, and our first step is to solve the parentheses by simplifying. This is what we get, our first term, and then we're gonna multiply by 3. So we're gonna get 3x squared minus 18x plus 27, and then we have our plus 2, and then we just add these two. And that's our final answer. Now the root form. The root form is simply just putting the terms in a different order. This is our equation, and what we have to do is get our x's. This is our x1 and x2. We can do this by concluding the general form or by passing to vertex form like we have already learned. So these are our terms. x1 is equal to 1, x2 is equal to 3, and a is equal to 1. What we have to do next is just change those into this formula. That this is our root form formula. So we have y is equal to 1, x minus x1 is equal to 1, and x2 is equal to 3. And that's our final answer for the root form.